All right, today we're going to dive into a really fundamental shift that's happening in AI right now. We're seeing agents transform from these simple reactive tools into something more like a sophisticated architect, a system that can actually plan. And this isn't just some small update, you know? It's a massive leap forward that's unlocking a ton of new possibilities. So let's get right into it. So here's the big question, right? How do we get from a simple chatbot to an entire team of AI consultants? I mean, how do you actually build a system that can take on a really complex, multi-step goal and just run with it, you know? See it through from start to finish all by itself? Okay, to make this real, let's imagine you give an agent a super tough question. Something like, hey, what's the deal with global silver reserves right now? And where's all the money flowing? Now, this new generation of agents, they don't just do a quick web search. Nope. They start by researching complex global markets, kind of like a real financial analyst would.
And then, instead of just dumping a bunch of links on you, they go out and autonomously browse dozens of different sources. They're pulling in raw data, articles, reports, the whole shebang. But here's the key. They actually synthesize all that information. They're looking for the patterns, right? Identifying key trends, supply deficits, investment flows, all the important stuff.
And this is where it gets absolutely wild. After all that work, all that research and synthesis, they don't just hand you a report. They can actually build an interactive dashboard from scratch. I'm talking visualizing the data with charts, key metrics, everything. They turn your complex question into a real, usable application. It's incredible. So, how in the world is any of this possible? Well, the secret isn't just make the AI model bigger. It's about a completely different architecture, a whole new way of thinking. We're moving away from simple, repetitive loops and into the world of dynamic, intelligent graphs. Let's break down what that actually means. Okay, this image right here, it tells the whole story. On the left, you've got the old way, a simple repeating loop. You know, the AI perceives something, makes a decision, does a thing, and then starts all over. It's just reacting. But look at the right. That's the new way, a dynamic graph. Here, you have a planner agent that's basically the project manager. It creates a custom plan and then delegates tasks to specialized agents. You got a retriever, a coder, a thinker, and they can all work at the same time. See the difference? It's not just reacting anymore, it's strategizing. Now, to really get why this graph approach is such a game changer, we first have to understand why the old loop-based model just doesn't work for complex stuff. These first-generation agents, they basically hit a wall. There were three fundamental barriers that were just incredibly frustrating for developers. And those barriers are context confusion, greedy logic, and the serial bottleneck. These three things, working together, basically trap simple agents in this cycle of inefficiency. They're the reason these agents just can't handle truly complex problems. So let's break them down one by one. All right, first up, context confusion. So imagine this. In a simple loop, the agent shoves its entire history, every single tool call, every log, all the raw data, back into the model on every single step. It's like trying to have a conversation where you have to repeat everything that's ever been said before saying something new. After just a few steps, that history becomes so noisy, so overwhelming, that the model completely loses track of what it was supposed to be doing in the first place. The original goal just gets drowned out. Next up is what's called greedy logic, a loop-based agent. It's like a chess player who only ever thinks one move ahead. It just makes the best decision it can for the very next step, right now, with no thought for the bigger picture. It's super easy for it to get sidetracked on some task that seems important in the moment, but actually does nothing to help it reach the final goal. And finally, we have this serial bottleneck. This one's really simple, but absolutely crippling. The agent can't multitask. That's it. So if it needs to research, say, 3 different topics, it has to do them one after the other, after the other. It is so inefficient and slow, especially for anything complex that needs a few different things looked into at once. Okay, so how do we bust through these roadblocks? The answer is a totally new way of building these systems, and it's based on 4 key pillars. And we're not just talking about a small tweak here. This is a complete redesign from the ground up. It's all about rethinking how these agent systems should even work. So these 4 pillars are explicit planning, that's our architect, hierarchical delegation, that's the manager, persistent memory, which uses the graph itself as the brain, and finally, context engineering, that's the detailed instruction manual. Let's see how they all fit together. The first pillar, explicit planning, is really the big one. There's a great quote from AI researcher Phil Schmidt about this. He says shallow agents just kind of plan as they go, step by step. But deep agents, they use a dedicated planner to create an explicit blueprint, that graph we talked about, before any work even starts. This is what directly fights that greedy logic problem because it forces the whole system to follow a grand strategy right from the get-go.
So the other pillars are all there to support that master plan. You've got hierarchical delegation, which solves that context confusion problem. It does this by giving smaller tasks to specialized agents, and each one gets its own clean workspace. Then, persistent memory uses the graph itself to store information, so agents only get the data they absolutely need. No more information overload. And finally, context engineering is like writing a super detailed instruction manual for the AI. It makes sure it produces quality results and knows exactly what to do if something breaks. Okay, this all sounds great in theory, but what's actually under the hood? What's powering these dynamic graphs? Well, you might be surprised. The engine behind this isn't some fancy brand new AI framework. It's actually powered by classic mathematics, graph theory to be specific. And it often uses really well-established libraries like NetworkX to do all the heavy lifting. Right, so a graph engine like NetworkX, it's not really an agent framework. Think of it more like a pure math engine. It provides the physics for our agent system. And that physics gives us three critical things right out of the box. Parallelism, so we can run tasks at the same time. Really strict state management to keep information isolated. And resilience, which makes it way easier to recover when things go wrong. And this is where you can really see the magic. That single line of code on the screen, that's all it takes. A graph engine can look at this huge complex web of tasks and just automatically figure out which ones can be done at the exact same time. It mathematically finds every single opportunity to multitask, and the developer doesn't have to code any of that logic by hand. It's amazing. So, let's recap the key benefits here. First, you get parallelism for free. This makes things run so much faster. Second, the graph is the state. This is huge because it forces strict context isolation. A task can only see the results from the tasks it's directly connected to, and nothing else. And third, you get resilience. If one little task fails, you can just isolate that one part of the graph and retry it. You don't have to start the whole thing over from scratch. That's a game changer. Okay, so what does all of this mean for people actually building this stuff? This architectural shift, it's about more than just making better AI agents. It's completely changing the role of the developer in the AI world. Yeah, this quote on the screen just nails it. We're moving from chatting with a model to building a computer with models. See the difference? The old way was just prompting something and getting a response back. The new way is about using these large language models as powerful, dynamic components inside a much larger, carefully orchestrated system. This table really lays out the whole transformation perfectly. We're moving from just prompting a model to actually architecting a system. We're leaving behind simple loops, and we're now building complex graphs. And instead of trying to manage one giant, messy context window, we're factoring it, which is just a fancy way of saying we're breaking it down and only sending the exact right piece of information to the right agent at the right time. It's a huge shift from that vague step-by-step thinking to deliberate, upfront architectural design. So if you remember anything from this, remember these 4 things. 1. Don't build loops, build graphs. 2. Separate your planning from your execution. Let the plan be made before the work starts. 3. Factor your context. Keep things clean, don't let one agent's messy work interfere with another's. And 4. Treat memory as real infrastructure, not just something you stuff into a prompt. And all of this leads to one final, really exciting question. Once we stop treating AI agents like simple reactive tools, and we start building them to think and plan like true architects, the possibilities are just immense. So the only question left is, what are you going to build?